Let's see if you can figure out what this video is about. What happened? At 5:12 on Wednesday, April 18th, 1906, most people in San Francisco, California were asleep, but they were about to wake up very suddenly. The earth shook violently. One person wrote, "The ground seemed to twist under us like a top, while it jerked this way and that, up and down and every way." It lasted for only about a minute, but caused a lot of damage. Buildings toppled. People were trapped under rubble. Water and gas mains broke. Soon after the shaking had stopped, fires started burning the city. The fire grew out of control and burned for 3 days. It was an earthquake. What is an earthquake? An earthquake represents the motion of large blocks of the Earth's crust moving suddenly past one another because of the force of plate tectonics. The release of energy from this movement causes shaking at the ground surface. This release of energy and shaking are an earthquake. Why do they occur? When the giant blocks of rock that make up the Earth's crust are moved by plate tectonics, sometimes they slide smoothly past each other, but sometimes they bump into each other. The point at which the crust comes in contact is called a fault. When the surfaces do not move past each other smoothly and are not able to move along the fault, an earthquake may occur. There might be no movement along the fault for a long time if the blocks of rock are hitched together. As plate tectonic forces continue to push the rocks, energy builds up over decades, centuries, and sometimes over millennia. Eventually, this energy is released as an earthquake. This occurs when the rock breaks deep underground and moves to a new position. Where do they occur? Earthquakes do not occur at random locations and are not equally spaced. They are confined to narrow bands of seismic zones. Most earthquakes happen at or near the boundaries between Earth's tectonic plates because that's where there is usually a large concentration of faults. Some faults crack through the Earth because of the stress and strain of the moving plate. Other large faults are the boundary between plates, such as the San Andreas Fault on the North American west coast. While it is not as common, there are also some faults in the middle of plates. Movement along those faults can cause earthquakes too. For example, many strong earthquakes shook the Mississippi River Valley between 1811 and 1812. Although this area is in the middle of the North American plate, there is a large fault called the New Madrid Fault. This is the fault responsible for the 1811-1812 earthquakes. There are many types of faults. The first one is called a detachment fault, also known as a low-angle normal fault. A detachment fault occurs when the dip of the normal fault surface is very gentle, almost flat. This type of fault is common in the deserts of California. The next is a reverse fault, and these are a result of a compression, a force that pushes rocks together. These dip-slip faults happen when the hanging wall moves up relative to the footwall. The Sierra Madre Fault zone of Southern California is an example of a reverse fault movement. There are rocks of the San Gabriel Mountains being pushed up and over the rocks of the San Fernando and San Gabriel valleys. The next is thrust fault. There is a reverse fault with a gently dipping fault surface and are common to the Klamath Mountains of Northern California. The next is a strike-slip fault. Movement along this fault is approximately parallel to the strike of the fault. The rocks move past each other horizontally. A good example of this type of fault is the San Andreas Fault zone that runs along the surface of the Western California and can be seen for over 600 miles. And the last one is the Horsten-Graben fault. It occurs when normal fault surface is steep. The Owens Valley and Sierra Nevada fault zones in California are examples of these high-angled normal faults. These two fault zones together produce a down-dropped block which forms the Owens Valley. This fault-bounded valley is called a graben and the fault-bound ridge a horst. How often do they occur? Earthquakes happen all the time worldwide. Strong earthquakes happen more than once per month. Smaller earthquakes, such as magnitude 2 earthquakes, occur several hundred times a day. The 1994 earthquake in Northridge, California, for example, was about a magnitude 6.7. Earthquakes this size occur about 20 times each year worldwide. Although the Northridge quake is considered moderate in size, it caused considerable damage. The earthquake released the energy equivalent to almost 2 billion kilograms of explosive, about 100 times the amount of energy that was released by the atomic bomb that destroyed the city of Hiroshima during World War II. Locating earthquakes. Scientists locate where earthquakes occur using a system of triangulation. When an earthquake occurs, it causes vibrations called seismic waves that travel upward from the point where the energy was released. Like a stone tossed into a pond that sends concentric circles of ripples outward, the seismic waves radiate from the center of the earthquake. These seismic waves are what people on the surface of the earth feel when they feel an earthquake. Scientists record these seismic waves on an instrument called a seismograph or seismometer. By using the data from at least 3 seismographs, scientists are able to pinpoint the epicenter of an earthquake at the point where the radiating circles intersect. Measuring an earthquake's strength. Historical earthquakes that occurred before the advent of modern earthquake instruments were measured according to an intensity scale, sometimes known as the Mercalli scale. It is a scale based on a subjective measure. For example, the relationship between the number of buildings that toppled and the number of human and animal lives that were lost. Presently, earthquake strength or magnitude is measured by a Richter scale. Developed in 1935 by Charles Richter in partnership with Bino Gutenberg at the California Institute of Technology, the Richter scale uses a logarithmic scale based on 10. Incremental in numerical value, the Richter scale indicates a tenfold increase of the earthquake ground motion amplitude. As a result, a magnitude 4 earthquake is a relatively small one and only can feel some movement on the ground. A magnitude 8 earthquake is 10,000 times greater and can produce a devastating loss of buildings and lives. Earthquake damage on land. Earthquakes can cause a devastating amount of damage, both in terms of physical property and loss of lives. Earthquake damage at sea. A submarine earthquake can cause a tsunami, a series of large, damaging waves that ripple outward from the earthquake epicenter and inundate coastal cities. Earthquakes in the United States. Appreciably recorded earthquakes in the United States since 1700 range in strength from 5.3 to 8.7 in magnitude. The degree of damage was dependent on the earthquake's location. The 1994 Northridge, California earthquake cost $43 billion and it had a loss of lives of 72. What can we do? Because earthquakes cannot be predicted, our best course of action is to be prepared and have a plan. We will talk more about this planning and preparation in an upcoming screencast. The final slide is the vocabulary for this earthquake unit. Please write the earthquake-related vocabulary on your flashcards. We'll review this terminology in class. Thank you.